Hello and welcome to Applied Mathematics for Business, CQMS 110. I am Dr. Pauline Fu. In this lecture, I will talk about quadratic functions, equations. Topics include quadratic equations, solving quadratic equations by quadratic formula, discriminant and properties, factory quadratic polynomial, ax squared plus bx plus c, quadratic function, application of quadratic function, supply and demand functions, multiplying and division of rational expressions, adding and subtracting rational expressions, simplifying rational expressions. So let's take a look at quadratic equations, solving by factory. The quadratic function is in the form of yx equal to ax squared plus bx plus c. And in this case, a equal to 1, b equal to 5, c equal to 6. So this is the function, okay? Sorry, there should no equal sign here. This is the function. And if you let this function equal to 0, that is the quadratic equation, okay? So for this example, this is an equation. Without equal to 0, this is a function, okay? So how do we solve these quadratic equations? There are many methods. One is solving by factory. So remember in previous lecture, we talked about factory. So how do you factor left-hand side? Remember we have cross production. So the coefficient of x squared is 1, and the constant is 6, can be expressed by 2 plus 3 equal to 6. And when you cross multiplication, so 1 times 3 plus 2 times 1, it happens to be 5. So that way you decide the factory for left-hand side is x plus 2. And then x plus 3 equal to 0. And once you are here, it is obviously one x is equal to -2. The other x is -3. Okay. You can verify your solution by plugging these numbers into original equations. Make sure left-hand side equal to right-hand side. Okay. So let's look at the other example. Okay. Solve quadratic equation. This is the equation. Okay, equal to 0. So similarly, so we can try. So 8, okay, 8 can be expressed by 2 times 4 equal to 8. And 15, 3 times 5 equal to 15. And then when you cross multiply, 2 times 5 plus 4 times 3, it happened to be 22. So this arrangement is successful. So we factor the left-hand side, 2x plus 3, multiply 4x plus 5, equal to 0, okay? So let each bracket equal to 0, you get x1 equal to -3 over 2, and x2 equal to -5 over 4. Again, you can verify those solutions by plugging the solution into original equation. Make sure left-hand side equal to right-hand side, okay? So the factory, you need practice. The more practice you have, the more confident you will have on factory polynomials. The general expression for quadratic function, I mentioned before, it is ax squared plus bx plus c equal to 0. Okay, and the solution for this quadratic can use a formula. Okay, once you have a, b, c, you figure out this expression, that is your solution. Okay. For example, let's solve this equation using quadratic formula. So here, let's identify a equal to 1, b equal to 5, c equal to 6. Okay, so plug in the formula, x equal to 2a, a equal to 1, negative b, negative 5, plus minus square root of b squared is 5 squared minus 4 multiplied by a is 1, then c is 6. Okay, and then you work a little bit of this expression, you get 2x, x1 is negative 2, and x2 is negative 3. We did that before. Here we just show you how to plug in the formula. Okay, negative 3. So, and for this one, we also did this one using the factory. So how do you solve using the formula? I will just show you how to plug in the formula because we already have the result in the previous example. So a equal to 8, b 22, c 15. So x equal to 2a is denominator. So 2 multiplied by 8. Okay, negative b, so negative 22 plus minus square root of b squared, 22 squared, minus 4 multiplied by a is 8, multiplied by c is 15. Okay, so this is a used formula to solve quadratic equations. Oops. So we just talked about the quadratic equation can be given by this formula. Is there a situation that you don't have solution? So this is this slide. We are going to use discriminant to predict number, how many solutions do we have? What types of solutions do we have? This part, oops. Square root of b squared minus 4ac is a discriminant. Okay, and when this discriminant is a greater 0, we have 2 different solutions. Those solutions are real number. And when this discriminant, not actually discriminant refer to b squared minus 4ac, that is the discriminant. If this one greater than 0, we have 2 different answers in real number. Okay, and when this equal to 0, we have 2 same solution. That solution is negative b divided by 2a. And when the discriminant smaller than 0, we don't have solution in real number, but we do have solution in a complex number. That is outside this cost range. Okay. So this is the summary of what you are going to get, how many solutions you are going to have, and what type of solutions based on discriminant b squared minus 4ac. So now let's take an example. Found the discriminant and determine the nature of solutions. This is a quadratic equation. Okay, found the discriminant. The discriminant is b squared minus 4ac. Okay, in this quadratic equation, a equal to 3, b equal to 2, and c equal to 4. And you just plug in the numbers. So 2 squared minus 4 multiplied by 3 and multiplied by 4. Okay, and the result is 4 minus 48. Okay, and the result is negative 44. This number is smaller than 0. When you have discriminant smaller than 0, you do not have solutions in real number range. And this is the solution. So now let's take a look at this example. Found discriminant and determine the nature of solution. So discriminant is b squared minus 4ac. Okay, a equal to 1, b equal to 2, c equal to 1. So I'll just directly plug in 2 squared minus 4, okay, equal to 0. So in this situation, the solution, you only have one solution, okay? So that solution is negative b divided by 2a, okay? And negative 2 divided by 2. The result is negative 1. Okay, you can verify plugging negative 1 into original equation, you get left-hand side equal to right-hand side, okay? Application of quadratic function. This is an interesting example, and this example I just created out of my head. The railway distance between Beijing and Shanghai is about 1,318 kilometers. Two different high-speed trains are D train and G train. D train goes 110 km per hour, slower than G train. Also, D train ran in 6 hours more than G train. Found the speed of each train. So looks like there are two unknowns because the speed of each train, what is the speed of train, D train, what is the speed of G train? Because the speed has relationship, see, D train goes 110 slower than G. So we only need one variable. Let's let X be the speed of G train. And the D train is 110 slower than G. So the speed of D is X minus 110. So we know, so the speed of G is X, the speed of D train is X minus 10. Once you know the speed, we know the distance, you can figure out what is the time for D train running from Beijing to Shanghai. It is distance divided by speed. You can also figure out the time for D train is again distance divided by distance divided by the speed. Okay, let me see. Oh, this one here, see, D train runs 6 hours more than G train. Okay, so here 6 hours more. Okay, so let's consider the D train. The speed of D train is X minus, and we know speed times, there is no bracket here, okay? It is just this number distance divided by speed equal to time plus 6 hours more. Okay, so D3 speed is x minus 110. Speed multiplied by time, the time for D3 equal to distance. Okay, and do a little bit algebra, you can see we get a quadratic equation. Okay, simplify this quadratic equation, you get this format, and then use the general formula, and you get the final result. The final result actually has two numbers. We dropped off the negative number because the speed could not be a negative number. Okay. So that is one application, and the other application of quadratic function. Find 3 consecutive natural numbers such that the sum of their square equal to 50. Okay. So this is the answer, and I will provide the solution here. Okay. So consecutive natural numbers, 3. Let's say 1 is x. Because they are consecutive, the second number is x plus 1, and the next number is x plus 2. Okay. Those are the 3 consecutive natural numbers. The sum of these numbers equal to 50. So square each number, square each number. The sum means you add them together, equal to 50. Okay. And then you simplify the left-hand side. So x squared plus the second item, use complete square formula, x squared plus 2x plus 1, and plus this item, x squared plus 4x plus 4. Equal to 50. Equal to 50. And now you collect like terms, x squared here, x squared here. So there are 3x squared, 2x here, 4x here, so 6x. Finally, the constant 1 and 4, it is 5. Equal to 0. Okay, so again, this is the general format for quadratic function. Okay. You can use the formula and you get x equal to 3. The other x is a negative number, you dropped it. Okay. Once you get x equal to 3, the consecutive 3 numbers are 3, 4, and 5. Okay. All right, so next, let's look at the demand function and the supply function economics. The demand function is from, for example, consumer side, and we use x-axis represent the quantities demand, and this is the y-axis is the price. Okay, when the quantity increase, when the quantity of demand increase and the price dropped, this is the nature of the demand. Okay, so but when you write down the equation, we use Q as a dependent variable, P, price, as independent variable. So this is an example of demand function. So similarly for supply function, okay, y-axis, we use the price, P, and x-axis is the quantity supplied, okay, is Q. And this is an example of supply function. When you use quantity of the good, the price also increase. Okay. So this is the supply and demand function. When you plug those two functions on one diagram, this is price P and the quantity of demand Q. These two lines have intersection point. This point we call equilibrium. Okay, at equilibrium, okay, you have a number for the quantity. Okay, this quantity is the same as for supply and for demand. And also you have the price, the same price for demand and for supply. There is only this one point. Okay. If it is not this point, it is either excess supply. Okay, for example, if you are here, it is excess supply, and if you are here, it is excess demand. And if you have this demand function over here, and you have a supply function, and you can solve for at what quantity you reach the equilibrium. You actually solve these two equations together. You have two equations, two unknown. You can solve for this P and Q. So that is the supply and demand function. Now let's switch the gear, talk about fundamental principles of fractions, okay, rational expressions. The value of a fraction does not change if both the numerator and the denominator are multiplied or divided by the same non-zero number. Okay, this is the fundamental principle of fractions. Two fractions are said to be equivalent if one can be obtained from the other one by use the fundamental principle, either multiply or divide the same non-zero number. Okay. For example, if I have a simple fraction, 3/2, and this fraction would be the same as if I multiply by 4 on both numerator and denominator. They are the equivalent of fraction, okay? And if I divided this fraction, numerator and denominator, by 4, the same number, it is also the equivalent of a fraction. Now let's look at some examples. Equivalent algebraic fractions. Find the two fractions equivalent to this fraction. To find equivalent, we can, because when we observe, the numerator has a, denominator is also have a, we can divide a from both numerator and denominator. So numerator divided by a, denominator divided by a, and we get this fraction. This is the equivalent of original fraction. Okay. And we can also multiply the numerator and the denominator by a same factor. For example, 3a minus 1. So numerator multiply by 3a minus 1, denominator multiply by 3a minus 1, and you get this fraction. This fraction is the equivalent of original fraction. Okay. Alternatively, you can use 3a plus 1, 3a plus 1, and this is the result. It is also an equivalent of original fraction. As you can see, you can give many equivalent of fractions. So next we introduce the lowest term or simplest term. One of the most important operations in the fraction is that of reducing it to the lowest form or simplest form. Okay. So simplest form of fraction, if the numerator and the denominator has no common factor rather than +1 or -1. That is the simplest. So let's take a look at this example here. This is not a simplest because this fraction numerator, you have a factor a, denominator, you have a factor a. Okay, it is not. If you have common factor, it is not simplest. So this one is the simplest fraction, ax over 2, because numerator and denominator do not have common factor except one, positive one, negative one. So more about fractions. This is a property of fraction, not fraction, actually property of algebra. If you have x minus 1, it is the same as negative bracket y minus x. Okay. So we are going to use this, do this example, simplify this fraction. Okay. So for this one, on the numerator, x squared minus 1, we can use this formula. If you have, for example, x squared minus y squared, if you factor this, it is x plus y bracket multiplied by x minus 1. So use this formula, apply to numerator x squared minus 1, you get x plus 1 multiplied by x minus 1. And for the denominator 1 minus x, we use this property. Okay, we take negative side away, and then the bracket we have x minus 1. The purpose we are doing this, we want to cancel out this x minus 1 with this x minus 1. And we only have this negative x plus 1 left. Okay. So this is this one. This is a multiplication and division of fractions. A over B is a fraction, C over D, another fraction. If you want to multiply those two fractions, numerator multiplied by numerator, and denominator multiplied by denominator. So if you do the division, A over B divided by C over D, first, you put the division into the long bar here. That also means division. Okay, and then you flip the second fraction. Instead of C over D, you say D over C and change to multiplication sign. And then this becomes multiplication of two fractions. So numerator multiplied by numerator, denominator multiplied by denominator. Okay. Let's look at an example over here. Here on the bottom here, where is my pen? Okay, so 3 over 5 multiplied by 2 over 7. So numerator 3 multiplied by numerator 2, denominator 5 multiplied by denominator 6, and you get 6 over 35. Okay, and the same question if you have 3 over 5 divided by 2 over 6. Okay. So remember, you can use, this is division, you keep the first fraction, you flip the second fraction, and then change division to multiplication, and then numerator times numerator, okay? Denominator times denominator. So this is the division of multiplication. So lowest common denominator. So if the fractions to be combined do not have all same denominator, So for example, those are the fractions that do not have the same denominator. We must first change each to an equivalent fraction such that resulting fractions do have the same denominator. See, these resulting fractions, if you look at these three fractions that have the same denominator. So how can we go from here to our final destination here? Okay. So this is the process is called the lowest multiply of prime factors. We use a lowest common denominator. Okay. So let's do this example to illustrate the procedure of how do you find the common denominator for different fractions. So this question found lowest common denominator of these fractions. Okay. So now let's factor each denominator. The denominator for the first fraction is 8. We know it is equal to 3 raised to power 3. The denominator for second fraction is 4. It is 2 raised to power 2. And the last one is 20 denominator. 20 equal to 2 raised to power 2 multiplied by 5. Okay, so observe these three results. Observe here, we notice the highest power of 2 that appear is 3. Okay, and the highest power of 5 that appear is 1. So we know the least common denominator is 2 raised to power 3 multiplied by 5 raised to power 1. Okay, so we get this LCD. Once we get this LCD, every original fraction, the denominator changed to 40. So from 8, how do you change to 40? You multiply by 5. If denominator multiplied by 5, numerator also multiply by 5. So you get 5 over 40. Do the same thing for the other fractions. So you get 3 fractions with common denominator. Next example is about adding fractions using LCD. Okay, if you add these 3 fractions, as you can see, the denominator is not common. So first step, we need to find the LCD. Okay, LCD. Okay. So first step, what is LCD? Okay, it is 3r raised to power 2, then s raised to power 3. Okay, we did similar procedure before. So this is LCD. Once you identify this is LCD, every original fractions, the denominator must have this LCD. And you figure out, for example, for the first denominator, it is 3r squared. How do you change from 3r squared to 3r squared s raised to power cube? You multiply numerator and denominator by s raised to power cube. Okay, and you do the similar stuff. Make sure you go over this example by yourself and make sure you are very comfortable with combining the fractions that has different denominators. So this is another example. Okay, rational expressions. Okay, so the denominator is different. So our objective first step to find LCD. And the LCD is this x minus 1 plus x plus 1. And then you follow the rules to change original fractions denominator to LCD and figure out what you need to do for the numerator. And then you work a little bit algebra. Okay, so again, make sure you go over this example by yourself, copy down this expression to see if you can come up with this result. Okay, it is all about practice, practice, and practice. This is the complex fractions. Okay. A complex fraction is the one, the numerator, the denominator, both the numerator and denominator has another function. For example, this is numerator. The numerator has another fractions. This is denominator, also include another fraction. Okay. So how do you simplify? Okay. So you do 2 steps. Okay. First, you simplify the numerator, original fraction, something on the top. Okay. So you do this, and then you do the denominator, simplify the denominator. Okay. And then you use this is result of original numerator, the result of original denominator. You do the division. See the division here. Okay. Flip the second fraction, you change the division to multiplication, and this is final result. So again, make sure you do this by yourself from here. How do you go from here and to the final result? Okay. It is easier said than done. Okay. All right. So in summary, what we did in this lecture, we did the quadratic equations, and the formula is ax squared plus bx plus c equal to 0. And we use 2 different methods to solve this quadratic equation. One is factoring, the other is use general formula. Okay, and it is here, factoring and general formula. And the discriminant refer to the term b squared minus 4ac. That is the determinant. Based on determinant, we can decide, do we have 2 different real solutions? Do we have not one solution, or we don't have a solution in real numbers? And we did this factorial. Quadratic function, it is just this one represents quadratic function without equal to 0. So this is the quadratic function. And you have to say y equal to this one, or f bracket x equal to. And for the application of quadratic functions, we did 2 examples. One example of the high-speed tree, okay? The other example of natural numbers. How do you find 3 natural numbers? A square of them are together equal to 50. And we talked about the economic supply and the demand functions. How do you find equilibrium point? Finally, we actually just did the rational expressions, addition, subtraction, multiplication, and division. Okay, that's all for this lecture. Thanks for watching.